You might have heard that Australia's koalas are under threat, or that Tasmanian devil populations are declining. You might even have heard about kangaroo populations growing too large. But how do we know these things? When you hear news of animal numbers going up or down, do you ever stop to think about what's involved in working that out? I mean, counting animals sounds easy, right? You just walk into the bush and start counting. But really? How do you get to where the wild things are? And when should you go? Summer? Winter? Daytime? Overnight? And how many times is enough to see what you need to see? Australia is an enormous continent. Our landscapes can be rugged, densely vegetated, rocky, sandy, even spiky, with conditions ranging from extremely hot and dry to tropically wet and humid and everything in between. So, how does that animal counting sound now? Thankfully, for ecologists like me, there is a growing range of exciting technologies known as remote sensing that collect data for you. We can now make just one trip to a place that's hard to reach, set out a bunch of camera traps or sound recorders, and leave them there for weeks or even months to be our eyes and ears in those wild places. We can also use drones to take pictures from just above the landscape. And there are satellites collecting images across whole countries from afar. But collecting data is just one step in understanding our animal populations. In my research, I'm collecting many types of remote sensing data and combining them in mathematical models that can tell us what sort of things matter to an animal choosing a home. My models exploit the differences in these data to represent different processes, some that affect whether an animal chooses to live in a place, and some that affect whether we can see or hear it if it does. I'm experimenting with different combinations to work out which ones can tell us new and important things. And because remote sensing produces huge amounts of data, I'm also enhancing the way we use artificial intelligence to identify animals and to seamlessly connect AI processing with remote sensing models. This will make it easier and faster to understand our animal populations so we can look after them and their homes while there is still time.